Far beyond Earth, nearly a million miles from our planet, the James Webb Space Telescope drifts silently through darkness. Protected by a massive sunshield and equipped with vast golden mirrors, it peers deeper into the cosmos than any telescope before it. But JWST does more than observe distant space. It observes distant time. Every photon captured by the telescope has traveled across unimaginable distances for billions of years before finally reaching its mirrors. These ancient particles of light began their journey long before Earth existed, carrying with them hidden records of a young and evolving universe. To look deeper into space is to look backward through time itself. A galaxy from the dawn of creation. During one of its deep field observations, JWST focused on a distant galaxy known as GSZ 13-0. Its light comes from a time less than 300 million years after the birth of the universe, an instant after the Big Bang on the cosmic timescale. What astronomers discovered there was unexpected. Despite existing so early in cosmic history, the galaxy appeared surprisingly mature. Within its compact structure burned vast numbers of young stars, radiating enormous energy into the surrounding darkness. But the real surprise was hidden inside the spectrum of its light. Astronomers detected evidence of oxygen. That discovery changed everything. The universe grew up faster than expected. In the beginning, the universe contained mostly hydrogen and helium, the simplest elements in existence. Heavier elements like oxygen, carbon, and nitrogen are forged inside stars and released into space only when those stars die in powerful explosions known as supernovae. Finding oxygen in such an ancient galaxy suggests that multiple generations of stars had already formed and died astonishingly quickly. The early universe may not have evolved slowly and quietly. Instead, it may have erupted into rapid cycles of star birth, stellar death, and chemical enrichment far earlier than scientists once believed. Massive stars formed quickly, burned intensely, and exploded violently, scattering newly created elements into surrounding space. Those elements then seeded the next generation of stars, accelerating the evolution of galaxies across the cosmos. In galaxies like GSZ 13-0, astronomers may be witnessing the universe's first great factories of cosmic chemistry, places where the ingredients for planets, oceans, and eventually life itself were already being created. The universe was never calm. As JWST continued its observations, another surprising truth began to emerge. The cosmos is not orderly or peaceful. It is dynamic, violent, restless. Even the earliest galaxies appear more massive and complex than expected, some possibly harboring rapidly growing black holes at their centers. These discoveries challenge long-standing models of cosmic evolution. Rather than unfolding gradually over billions of years, the young universe may have experienced periods of explosive growth and extreme activity almost immediately after its birth. And that realization is reshaping humanity's understanding of how everything began. But the telescope's discoveries did not end with ancient galaxies. In Part 2, JWST turns its gaze closer to home, toward failed stars, hidden moons, chaotic planetary systems, and worlds slowly being destroyed by the gravity of their own stars. After studying blazing galaxies from the dawn of time, the James Webb Space Telescope shifted its attention toward something far smaller and stranger. A dim object drifting silently through space. A brown dwarf. The mystery of failed stars. Brown dwarfs exist in the strange boundary between planets and stars. They are larger than gas giants like Jupiter, yet too small to sustain the nuclear fusion that powers true stars. For years, astronomers believed these objects were relatively quiet and inactive. But JWST revealed something far more complex. Inside the dense atmosphere of one brown dwarf, scientists detected methane, water vapor, and thick layers of swirling clouds. Subtle variations in brightness hinted at violent storms raging across its surface in complete darkness. Even more mysterious were faint glowing structures high in its atmosphere, aurora-like displays resembling Earth's northern lights. Some astronomers suspect these strange lights may be caused by an unseen moon interacting with the dwarf's magnetic field. If true, it would mean the presence of an invisible world is being revealed indirectly through the disturbances it creates. Chaotic planetary systems. The telescope next observed a massive exoplanet orbiting a distant star along a highly unusual path. Unlike the nearly circular orbits found in our solar system, this planet travels in a stretched and tilted orbit shaped by past gravitational chaos. Scientists believe its system may have experienced violent interactions long ago. A giant planet passing dangerously close, a companion star pulling on the system, or even an interstellar object disrupting planetary formation. These observations suggest many planetary systems are far less stable and orderly than our own. Gravity can reshape worlds, alter orbits, and completely transform the architecture of entire systems. A planet falling into its star. In another extraordinary observation, JWST witnessed a giant gas planet slowly spiraling toward its parent star. With every orbit, tidal forces pull the planet closer. As the distance shrinks, intense gravity stretches and heats the planet's atmosphere. Eventually, its outer layers will begin to tear apart. Streams of glowing gas may one day spiral into the star like rivers of fire. In time, the entire planet could be consumed. These scenes reveal an important truth: planets are not permanent. Some are ejected into deep space. Some collide with neighboring worlds. Others are destroyed by the stars they orbit. The endless cycle of creation and destruction. When scientists connect discoveries like these, ancient galaxies evolving rapidly, hidden moons shaping distant atmospheres, chaotic planetary systems, and dying worlds, a powerful picture begins to emerge. The universe is constantly changing. Stars are born in immense clouds of gas and dust. They shine for millions or billions of years before dying in colossal explosions. Those explosions scatter heavy elements across space. From that debris, new stars and planets form. And on at least one of those planets, Earth, life emerged. The oxygen we breathe, the carbon in our bodies, and the iron deep within Earth's core were all forged inside ancient stars that died long before the Sun existed. In this sense, destruction and creation are not opposites. They are partners in an endless cosmic cycle. A universe still unfolding. The deeper JWST looks, the clearer one truth becomes. The universe is far more active, chaotic, and surprising than humanity once imagined. Yet within that turbulence lies extraordinary beauty. Galaxies collide and give birth to new stars. Exploding suns forge the elements needed for life. Chaotic systems create new worlds. And somewhere among countless distant planets, other living worlds may already exist. As the James Webb Space Telescope continues its silent journey through space, it gathers more ancient light from the deepest corners of the cosmos. Each new observation expands humanity's understanding of where we came from and how the universe became what it is today. Some discoveries will confirm what we believe. Others may challenge everything we think we know. But with every photon captured, humanity moves one step closer to understanding the vast and mysterious universe we inhabit. A universe whose story is still unfolding billions of years after its fiery beginning.